Hey there guys, and welcome back. So we are back here working on the mini quote-unquote CNC machine. And after the stream yesterday, I had some ideas. Sitting there thinking about it before going to bed, and I came up with a couple solutions here for this problem. And the problem being is that I keep on adding stuff here and it keeps on getting longer and longer. And I was trying to keep it as short as possible at the base. So, what are my solutions? First one I came up with is moving these angle brackets to the outside. Now, I didn't like that one as much because I was trying to keep everything as short as possible, so I'm just taking one problem, which is this being a little bit longer to accommodate the angle brackets, and making this one longer and the back one longer to compensate. Now, the fact of the matter is that is still not a terrible idea, and we will be incorporating that into the front. The reason we will be incorporating that into the front is because on the front side, I can have stuff on mounted to the front side, right? Like if we look at, let me open up the examples again. We can really open up any of these because they all do it. So you can see on the front, we've got this little touchpad here on the Snapmaker. On the Person Mini, we're going to have the touchscreen on the right hand side, right, mounted to the front. So having stuff out front is cool. It's you know, expected to some degree. So actually, I guess the Person Mini, again, I don't own a Person Mini, but I guess that's not a touchscreen since it has the toggle knob. So anyway, point being is that I can make use of that in the front. The backside, however, is a different story. And the other problem the backside had was back to, as it turns out, once I got this in place, I realized the belt is going to be running into this extrusion. Well, I was in there thinking, and I should have left this open, but we could just do this. We could just put a piece on the back and have a hole in it instead of having extrusion. We don't need extrusion back here. We can put tap holes, tap the two extrusions here. They're going to have angle brackets in the front. Again, this is a smaller model, so I'm not that worried about these, what is this, the y-axis, well, the y orientation at any rate, flexing too much. I'm not that worried about it. So if we tap these and then put a plate across here, we can put a hole in the plate, easy enough, for the belt to go through, and then that solves our problem. As for the base, again, the belt's going to be running across here. So it's probably, the base will probably be high enough, but even if the base is not high enough, we can always build the base up a little bit to clear the belt, which was the other concern that I didn't quite touch on. I don't think as much as this extrusion being a problem last time, but that is something to keep in mind. So all that being said, let's get those changes put into place, and then we can finish off the bed. Well, actually, we'll have to redo our math here on this section right here, and then we can finish off the bed. So, actually, I'll do that first, since we should have everything, if I recall correctly, annotated. All right, we do not have everything annotated. So these right here on the angle brackets, and actually, it looks like, okay, yeah, I only have one because we multiply by 2. I was going to say, it looks like we only have one angle bracket. We can take that out completely now because the angle brackets will not interfere with the wheels. We had to put that in there because the wheels on the other side of the bed were going to be impacting them, and we needed to clear them. So that is no longer an issue. And let's see. I think the rest of this is fine. So there's that, and again, we are going to have to realign this stuff because it does not happen automatically. Actually, we have a little bit different of an issue because this is the part that we placed in first, and then we mirrored it across the center axis. So we actually need to delete that, and yeah, that's part of the rigid group, so this is going to pop up here. We want to actually realign this to the front is how we want to do this. So we want to figure out where that is. Okay, that's the angle bracket. There we go, there's that. We'll realign that guy. We'll keep the same face, I think, touching the extrusion. Just get him down here. I don't really want to click any of these circles. There we go. Nah, yeah, see, I was just going to hit the flip button is all I was going to do. It's one of those things. Its internal orientation is going to be a little wonky, but at the same time, I don't particularly care, only because it's not doing anything. It's just basically a solid body is all we're using it as. So it's not that big of a deal. And we can go ahead and clear that, or not clear that, but obviously you can see this plate came all the way with us. We'll have to fix that. I think I'm going to roll the history marker back just so I don't have to deal with those guys for the moment. This guy, when do we change the extrusion? Let's move that back then. Or move that forward, whichever one works. Okay, I'm gonna roll here. And now we're going to pick this guy up. And let's see, how do we want to reorient this guy? I guess I'll just do it this way. Grab that, go to there, flip it. The way it's see-through is just bugging me a little bit, messing with my eyes. Get that aligned against there. Again, we're gonna have to flip it back. Okay. And its vertical should be exactly where it was before, I think. Yeah, I think it's vertically exactly where it was before, so we don't have to fix that. In the Z dimension is what I'm talking about. And for right now, I'm going to go ahead and finish position, and we're just going to extrude this out. Let me find the back extrusion, and actually this is the front extrusion now. I'm just going to extrude it out to the length of the base here. Huh, where's my two object? Oh, we're on symmetric. I do not want to be on symmetric. Two object. Actually, you know what? I guess I do want to be symmetric, don't I? No, I guess I want to be two-sided, in which case I want to do this after we mirror that over. Okay, fair enough. Get our ducks in a row. So we'll mirror this guy over first, so he's on the other side, and then we will do two-sided extrusion instead. Not that. Two-sided. There we go. That to that, and two object. There we go. And I wanted this guy. Okay, never mind. I don't want that guy. Is there a minimum distance? There's not a minimum distance, right? Okay. So let us attempt to click this edge instead. Nope, not gonna happen. Okay, you know what? It is what it is. I'll take it. Not gonna fuss over it right now. Looks a little spiffy, frankly. And join. And okay. Why did we not join? Control Z. Hop in here to front extrusion. Try that again. Two-sided. Two object. That way. Huh, what did I click there? What object did I click there that actually got me pretty reasonable? Don't know. And the other side, two object. There we go, and join. Alright, much better. Still one object now, instead of multiple objects. So that's the front side fixed. This extrusion right now, let's double check where it's at. So it's at 307. I wanted to get something more like 270, but I don't think we have that option at the moment, so we'll learn to cope. Fix the rigid group since we don't have an extra extrusion now. There's that. Alright, and then that's the bracket. So we're actually going to... I think we're going to delete everything after here. We could just delete that stuff. The origin group is still relevant, so... But the rest of the stuff we're going to change. So as for this back plate, it is one of these things where normally, if I was just doing this myself, I'd actually go into work, grab a small piece of scrap because it's quite small, throw it on the plasma cutter, and cut this piece. That would make it more rigid. It's one of those things. So half-inch feels like a little bit of overkill. I don't think I have any quarter scrap sitting around, so I'm down to 3/16 after that. I don't have anything in between there in terms of just leftover scrap that I keep in my pile. So in that case, point being, where I was going with this, it doesn't necessarily matter what I would do if I was using the plasma cutter. I'm not using the plasma cutter. I'm going to 3D print this simply because this is a model I'm doing on stream, and therefore I want it as accessible as possible. And most people, I imagine, who are actually following this design stuff have a 3D printer but may not have the other tools. So one of those things. All right. Just thinking. This is hiding under bed, right? Yeah, it is hiding under bed, unfortunately. So we're gonna come in here. There's the motor bracket. I'm gonna rechange this from motor bracket to back plate, and the motor bracket's going to be built into the back plate. There we go. Now, my construction line. Did we have that? Back of motor assembly. Where are you hiding? Okay, that was the that is no longer accurate at this point. That would have been, I should go back and delete that guy. That would have been if we were trying to keep the motor inside of the frame, which we completely gave up on. So that is no longer even an option. So that guy should probably just be deleted. Otherwise, what I was looking for was the back of the extrusion. So where is back extrusion? Right extrusion, front extrusion. Oh, yeah, that's right. We don't have a back of extrusion anymore. That would explain that one. Front extrusion, technically speaking, is what we have now, but I do not have any constructions in there. So we will go ahead and just put the construction plane on here ourselves, since we do not have it. And since this is inside the back plate, I will call it front of back plate. And give me half a second to turn off my fan because I just realized it's still running. I was soldering the project up this afternoon, a new PCB, or not a PCB, it's not a real PCB. It's one of those, what do they call these? I mean, they call it a PCB kit. Alright, I guess they call it a PCB plate kit. It's not perf board, it's the fancy perf board with the, what do you call it? With the ringlets on it. What do they call the ringlets? Plated holes, I guess, is what they call them. So it's basically fancy perf board with plated holes is what I use. I actually tried finding perf board for PCBs because, you know, Great Scott uses it all the time, and he says it's cheap. And I could actually find it sourced locally cheaper than what I got this stuff for. So one of those things, weird situation. Regardless, onto this back plate. Obviously, we're just, why is this at an angle? Huh, hold on. Let me hit the look at button. Why are we at an angle right now? That does not actually make sense. Are you at an angle? No, that's definitely a flat plane. Did I click something? instead of the plane to create my sketch on. Alright, Oh, I see what's happening. Okay, this is a matter of perspective. I'm seeing the bracket plate and the front edge of this extrusion right here because they're both slanted. So I'm seeing them, and I'm assuming I have to be off at an angle like this in order to see this edge, because this edge should not be visible from that perspective, but because of the way we extruded it, that is why it's visible. Okay, makes sense. So let us go ahead and grab these faces. These are the only two faces I'm worried about at the moment, and then we can go ahead and add the other features afterwards. We're going to make a flat plate first and then add features to the flat plate afterwards. Let's do that. Let's turn some stuff off. Turn the wheels off, don't need those. Turn the rest of the extrusions off, don't need those, and the corner brackets. And the motor I will turn off temporarily, but we do need the motor back in just a minute. So this only needs to be just as big as the extrusions. So we will go ahead and do that. Now I did talk about allowing this to be adjustable in and out to adjust for our wheels, because I wasn't 100% sure whether or not I shouldn't have the wheels a little bit tighter to avoid some deflection. The second I tap these and just use a bolt and no slotted hole, in order to make sure that it doesn't move, I should clarify, that we would lose that. I think I'm still going to put a slotted hole in here. The reason you would not do that, I should say, is the reason you would not put a slotted hole in here is because you want this to be rigid, so a slotted hole obviously allows play. Whereas if I just had a hole perfectly right on the center line right here, and actually, what were these again? This radius 2.75, so that's 4 or 5 and a quarter. So were they 5.5? No, that doesn't make any sense. I forget what these are supposed to get tapped at. I'm just gonna call this 5. We're just gonna call this 5 for right now. Anyway, point being is, if I just leave this as a hole instead of a slot, then this whole entire back plate can shift back and forth and stuff. And the angles, the extrusions rather, the extrusions are not held rigidly, potentially, you know, assuming the bolts come loose. So that is the reason why you would not use slots. I think I just talked myself out of using slots anyway. It's probably not necessary. It's probably just me being overly cautious here. The fact of the matter is that this plate is not terribly big to begin with, so if I got to reprint it once because I found out that the spacing on between the rollers needs to be a little bit tighter, then that's not that big of a deal. I'm only going to need to make like one adjustment, so that's only one extra plate, so I'm not terribly concerned. So the only other question is what thickness we make this. It is plastic. I can obviously add extra walls for extra thickness, for extra stiffness rather. So I'm leaning somewhere between. So before, when we were talking about the bracket last night, we were at 7 millimeters, I believe, if I recall correctly, on the thickness there. I don't mind it being a little bit less stiff for two reasons. One, because we do have the angle brackets up front, helping keeping everything square, so it's not as vital. And two, again, this is just a very small machine, so it shouldn't be at any rate that big of a deal. So we could just call it 6 and be done with it, and I think we will. All right. Now I'm going to come back in here as promised and toss this on here. So for this, I'm going to actually just use the largest part of the pulley, even though we don't need it. Technically speaking, the G2 pulley does not stick out past this rim right here, so we should have extra space anyway. So let's go ahead and use that as a reference point to draw our notch. And the bottom line catches on there. The top line Catches on there, and then we can just make this collinear right here. So there's that. And then the only other thing would be the bracket, but as mentioned last night, or as I did last night rather, I will just draw it from the side. So we don't actually need to do anything else on this sketch. Which, the fact of the matter is this sketch is kind of unnecessary at this point. We probably should have just we probably should have just included this notch on the previous sketch. But whatever, it's fine. It's like an extra, what, 1 kilobyte? Less than that of data. Not gonna cry about it. So now we need the front of the motor. Where is the motor? There's the motor. And do we have... Oh yeah, this is no modify in place, unfortunately. Oh, but it does have a plane. It already has a front plane. Good. Cool. Nice, nice. We can use that. So we'll hop on there. Actually, I take it back. This needs to be lined up before we do that. So let's hop up to the motor assembly. Modify, align. There is no reason why this can't be right up against this plate, so that's where we're going to put it. This distance left and right along the x-axis, according to our origin, this distance shouldn't have changed any. This should be exactly where we needed it at, so I'm not going to worry about that. I will, however, worry because the pulley does not look like it's in the place that we just put. Yeah. Oh, okay, I see why. Because we derp. Okay. Finish position. That was a little bit of a silly of me. Control Z, this guy. I took, obviously, this right here. And then just went off of that. My bad. We also need that guy. Project. Okay. And this is actually where our box is supposed to go. And actually, I will go ahead and just... I was going to say I'll just make it that big, but there's no real reason to, so... Probably better to just keep it smaller. Alright, there we go. Now that's lined up. Cool. Awesome. Everything's lined up. We are ready to rock on this bracket. So back to this plane right here as soon as I get into the back plate. Onto that plane. Project that out, and we're just going to do the same exact thing that we did yesterday, which is just grab a lines and trace this out. And I believe I also went, let me grab this and do, actually before I do that, turn these back to solids. And now I think this is what I did last night, was tossed another square on top of this, if I recall correctly. There. That is collinear with that, and this is collinear with the wall. And now we just need to line all this stuff up, so that's right angle to the wall. That is coinkydink with the wall. Tangent to the circle. Same thing over here. At a right angle. And then coinkydink to the top. And now we can just turn these mounting holes back to solid so that we cut them out. And we can extrude that. And again, I believe 7 is what we ended up with last night. And also, as I recall, we did this. And then rounded off these corners. And just these corners, because the bottom corners in theory is where we're printing. So 5 is fine. All right, cool. So that catches us back up to where we are last night with all the changes that I wanted to get done for the base. So that is most everything. All right, so we just need to do the bed. Let's get that red back in here. Red plastic. There we go. And you are one piece, right? I'm pretty sure this is one body. One of those things. Yeah, okay, that's definitely one body. Alright, on to the bed. Now the bed, I said was 6 inches wide. Let's see. What did I move? Revert position. There we go. And let's make sure that we're just at the end of the timeline before we start messing with other stuff. I think I'm going to go ahead and mirror these guys over right now. So mirror these guys across the center plane before I draw the bed. Earlier last night, I was talking about drawing half the bed and then mirroring the bed over with everything else. But that was going to be mirroring half this extrusion and that extrusion, etc. That was going to mirror absolutely every part of this base, and we are no longer doing that. So, since we're no longer doing that, it is no longer necessary to wait to mirror these wheels over. I'm going to come back up here to components and grab some of those eccentric nuts to throw them on this side. Okay, modify align. Need you to be inside of there. Flip you upside down. And then try to Control Z. I wanted to, let's see, which roller is this guy? That guy? Alright, there we go. I want to get him lined up with the face is what I wanted to do, because he's a little sunken in there right now. Okay, and capture position, and then we'll grab the other guy. No problem, easy peasy. And for the rest of this bed, it's one of these things where, again, it's not really necessary to do anything fancy with it, because it's just going to have stuff sitting on it, and the stuff is not going to be terribly big. Not going to be terribly big, and it's not going to be terribly violently attacked is how I'll say it. That looks like it sunk back down. And that being the case, it's not clear that it needs any special reinforcement or it needs to be specifically thick. So one of these things where, so long as it's over top of this guy, we should be fine. So I'm going to go ahead and hop back into the motor assembly really quick. And I'm going to have to use the motor assembly because, again, you can't edit in place. So, at least I can't edit in place, I should say. Let's capture position really quick. And I want to throw this tangent plane on here to make sure I know where that is, what we need to clear on the bed. And I want to reference the origin, and we are on the correct side, so I don't have to do 180 degrees. This is the top of the pulley. Well, top of pulley. I normally leave the out. Back to the bed, and I will use that to start drawing the base, and I'm going to go ahead and extrude down to the these nuts to begin with. So let's go ahead and project all those guys. That looks like an edge instead of a face. Let me fix that because I want the center hole as well. Okie dokies. So that should be everything. And then we can start turning stuff off. And the extrusion's off. Let's look at this. And one of these things where in theory, obviously you can see how these are eccentric, right? So I'm going to toss this in here to give me my center point. Toss, actually, toss, how do I want to line this up? My point is that I want to make sure that the bed is centered on these guys, even though these outside parts are eccentric. So if these were all spacers, I'd actually just do what I normally do with the tangent and tangent to there and then do an offset. I can't do that though this time. So this 6 inches right here, whoops, 6 in, there we go. I need that shifted over, right? So the question of how to do that, because I also want it centered on here, right? And this is going to be 8 inches. Yeah, all right. I guess I'll just go corner to corner. I wasn't sure if I wanted to go corner to corner, but it makes sense. So regardless, just wanted to think about it and make sure I wasn't jumping to conclusions here, but it makes sense to do it that way. So there is our bed. And then these eccentric nuts I want to, whoops, not C. I don't want to circle. X. I want to make these construction lines and then redraw spacers around them. And I'll make these spacers equal to the spacers that come over here. And the reason I'm doing this is because I'm going to extrude those down from the center of the bed. It looks like I missed the center part of the circle here, so let's go ahead and get that. Find that spacer, that guy, and I'll just grab the edge since we evidently did not grab the face to begin with. So rather than re-project the face, I'll just use the edge, point being. So right now we should be, in theory, some amount above the spacers is where we should be at. So I'm going to go ahead and turn these back on, just the spacers and the eccentric nuts. And in theory, the eccentric nuts are the same height as the spacers, if I recall correctly. Yeah, it looks like they are. So it doesn't matter which one I grab, but I want to extrude this down to those guys. And this way, the bottom of the bed is guaranteed to be... looks like I did not get the face there. There we go. Now the bottom of the bed is guaranteed to be above the pulley. And this is going to actually be the actual bed. One of those things, I shouldn't have called this bed. Well, I could have called this bed. I'm going to call this bed assembly. One of those things. The bed itself is actually different from the whole entire setup here that I'm calling the bed, which is why I am making that clarification. And hop in here, grab that sketch that we just had, and draw the bed. And this profile plane is exactly where it should be. In theory, I could go ahead and do, from object on these guys just to be extra safe, but that is a bit overkill, so I will not. And this is how the bed will be mounted to the rest of that. And now again, the bed itself, actually I may not do the bed out of steel from work, just because the bed I want to have as little bow as possible. Now the fact of the matter is that we're not putting a heated bed on this, so there's absolutely no problem with me printing the bed, which is probably what's going to happen. But the only other thing to mention is, even if I did have a steel bed that was slightly warped, one of those things, if you've used a, let's say, Ender 3, an original Ender 3, then, or any printer before that, really is what it comes down to, you know that you can more or less fix a warped bed just by sitting a piece of glass on top of it. That's what I have on my Ender. I've got a piece of glass as my bed. Well, sitting on top of my bed as my actual work surface to print on. So one of those things, even if I grabbed the piece of metal from work, plasma cut it out, it was a bit warped, it wouldn't be that big of a deal so long as I used another material on top of it that I knew was flat, i.e. a sheet of glass. Also, I'm not building a printer, as I stated before, which is why we don't have a heated bed. And furthermore, the point of that being is that the flatness of the bed probably is not as vital as with a printer, because stuff I'm putting on here in theory is going to have its own geometry. So one of those things with a printer. You're starting from the bed, so you want to start from a flat purpose and build up. Flat surface, not flat purpose. You want to on purpose start from a flat surface at any rate, and then build up from that flat surface. But anything we do on this, the materials are already going to be assembled, and I'm not expecting, again, as I stated before, to turn this into a router or anything like that. So because I'm not turning this into a router or anything, I don't even necessarily need the bed to be perpendicular to the spindle, quote unquote. Now, that being said, maybe I do end up putting a little laser engraver onto this thing for fun, but that's down the road. And in that case, I would absolutely want and need the bed to be perpendicular to the laser, to the z-axis. So it is to some degree important, but I'm just pointing out that this little machine that we're building right here is not as vital as many other machines for that to be the case. And with all that being said, we'll make this 6mm just like everything else. And I want to come back in here and countersink the bolts. Now these are 5mm. I believe 5mm is 3mm head on the button heads. It might be 3.5 on the knobbed heads. I actually don't think I have any of the, whatever you call them, thumb screw heads, whatever you call those guys, for the 5mm. I think all my 5mm screws are button heads anyway, so we'll just go with the 3mm there. Grab some coffee. Coming from the top of this guy, this is going to be top of bed. Construction line. Top of bed, trying to keep organized. Project, and then draw out the button heads. Which actually, one of those things, 5mm are not one of the sizes that I keep in my brain as to the size. I want to say it's something like 7.4 or 7.3 or something like that, but we're going to find out for sure. Alright, 5mm. Nope, way off. More like 9.25. Close to 9.25. We call it 9.25. One of those things, as I move the thing around, in theory, the largest diameter that I get is the diameter that I should use. It's technically, I think, closer to 9.3, so we'll just do that. And it does not matter if I have, you know, 1/4 of a millimeter more over the button head. So we are just going to go with 9.3. Use the equal sign. Extrude out. And since I have the box out right now, let's check. I was guessing 3, and it does in fact, alright, so 3 would actually be a very safe number. I actually could get away with 2.8, it looks like. I will go ahead and call it 3, though, just because I don't want it accidentally sticking out and getting in the way of anything I put on the bed. So we're going 3 to be extra safe, and as always, even though these are slightly oversized as is, I'm going to go ahead and relieve them just a little bit for the 3D printing part to make sure that we have tolerance. The actual 5mm hole going through, not as worried about. And let's go ahead and make this a color. I'm thinking green right now. Library plastic matte. There we go. Green is what I'm thinking. Green is what it gets. Turn everything back on because there's not any. Oh, I take it back. I take it back. So this is going to be printed like this, so we can actually install the limit switch button and the what do you call it, the pulley holders, the pulley tension, they're not even the tensioners though, they're the pulley. Actually, that's a good point. One thing I should do, let us back up while it's on my mind and I don't forget it. We're gonna hop back over to the motor assembly, and we're gonna come in here to this guy. to the bracket. And what Prusa does, and do I need multiple? I do need multiple. Okay. Let's see. Let me look really quick. Okay, their y-axis is off the ground. I've got mine on the ground. So the trick here is they've got a neat little thing for tensioning this. Adding minor tension to it at any rate. You know, not huge tension changes, which you shouldn't really need. It doesn't really deform that much over time, belts. But for the minor tweaking of the belt length, they have a pivot on their brackets, which is what I want to add here. The problem is that I can't pivot against the ground, unfortunately. Actually, I take it back. If I pivot it over this back corner, I probably can. So this, if I pivot around this back corner, it does lift the bed up is my only issue. So if you look at this circle here, this is in theory my pivot point. You can see as I go up, or as I pivot around this circle off of this corner, this point, which is the center point of the motor and therefore the center point of the belt, does go up. Now the fact of the matter is that that may not be that big of a deal. It may be that we are perfectly happy with that and it's not going to affect too much. For example, if I only make the slot just so long, you know, if I only make it, let's say, remember a 1/4 inch, something like that, 1/4 inch, then we're probably not going to pivot that much around. Now the other solution is just to draw my, just to do slots on all 3 of these and just pull it straight back, which is probably the easier way to do it and probably the way I should do it. The only reason I would not do it that way is because it's just harder to make sure you have the tension. With the nice thing about the pivot maneuver here is you put your hand on this and then you just kind of rock your hand right, and that's really easy to do. So you're holding with one hand and rocking, and that rocking against the pivot point right here is what keeps it in place. If I loosen up all 3 of these bolts and then slide them along this slot, then I've got to really make sure that I'm holding and keeping tension evenly across 3 bolts. Now, again, this is one of those situations where I am probably overcomplicating things and I should probably just shut up and do it, but I want to have it at least said at any rate. So, again, a 1/4 inch is what, like 6-7 millimeters, I think. So, I mean, this feels a little big. We'll go 6 millimeters. 6 millimeters. And you're going to be tangent. Actually, let me draw the other guys in really quick. 6. There we go. And 6. There we go. All right. And then you guys get to be tangent to that guy. Whoops, not you. Actually, that line could be tangent, but I prefer to get the circle. Technically, it is perfectly valid. You, Gale, what's up? Perfectly valid to be tangent to the other one. With the other one, with the line. Toss this guy in here as a reference so I don't have to do math. And then we just leave ourselves, let's say, 4 or 5 millimeters. I guess 4 millimeters makes me feel better off the back. And there we go. Now we can tension the belt like this. And now the only question is whether or not it extrudes correctly, and it did not. So we'll fix that really quick. There we go. And honestly, the whatchamacallits up here are fine. The fillets up here. All right, cool. So now we can hop back to the bed and get back to what we were working on, which was the other side of the bed and the capture points for the belt and the limit switch stop. So we'll turn again, trying to keep organized here. This is bottom of bed. Bottom of bed. We've got a little bit of ice cream left. Let me just finish that off really quick. Alright. Actually, I didn't even... I just realized this is kind of silly to have the bottom of the bed here. I don't actually need this plane because it's easier to just draw the side view of these capture points. Flip you upside down again. Project that out. And project out our belt. Where are you at? You around this side? There you are. Alright, cool. So again, the belt will sit below that line right there. So long as we are within that, we are fine. We can use that as a reference. Turn the stuff off so that we can see what we're working at a little bit better. All you guys. And now... that is a construction line. That can be a construction line. I guess I should have the... yeah, I guess I should have the wheels as well. So let's go ahead and add those. At least, maybe not the wheels, maybe just the standoffs here, just so I have a reference of where I'm going. Now, the interesting thing, and I don't know why they do this. It may just be to cut down on the number of parts. And actually, you know what? That's probably why. So when you look at the bottom of beds, and back to I have models here. So you see how this is the part we're about to build right here. So the belt comes all the way to this point, but it's one of these things I always look at this and I say, well, the belt doesn't really need to come that far. The belt could just go to the front and back here of the bed and should be fine. Actually, no, I take that back. Okay, back to our overhang. Okay, but our overhang, point being, stops where our sliders stop, which in our case is the wheels. So for this bed, in that case, yeah, this is, they only have the one set of linear bearings. Oh no, there's the second set. So it has two on one side and one on the other. Okay, that's what it looks like. Anyway, so long as... yeah, see? Okay. So several things here. One, the limit switch, which is... let's see. Where is the limit switch on this guy? I actually do not see the limit switch. Point being is that so long as the limit switch reaches, it's not that big of a deal. But this is within the these guys, which means this is the maximum that it can slide is up to this point. So if I grab this, whoops, that is not going to work evidently. I guess I'm not grabbing these guys. There we go. Let's see if I can multi-select here to demonstrate. There we go. So these guys in theory can move up to this point. They should stop before that, but my point being is that you see how this center point is still past, still stopping before the belt here. That's what we need to avoid. Was the entire point of this demonstration. Is just, oh, no, that should actually be, that's not connected. Good. All right. That needs to stop. Point being, this needs to stop before it collides into here. All I'm trying to say here. Trying to demonstrate with this model, but this model is not set up for constraints, so stuff is drifting off into space for me. So this is our wheel hubs right here. We need to stop before these hit the wall, right? Which means that the belt, so long as the belt is anywhere behind this line right here, we're fine. If the belt holder is in front of the line, then the belt holder crashes before the wheels, which, well, technically speaking, the wheel, you know, sticks out a little bit right here. But I'm just nitpicking there. So we can use this as a reference so long as we build this belt catch at or behind this point, we should be fine. And same thing with the limit switch. The limit switch just needs to be triggered before these wheels collide with the wall. And the limit switch can be on a slider itself to adjust the limit switch itself forwards and backwards. So wherever we put the little plastic piece that bumped into the limit switch on this bed is fine. So yeah, that should be everything. Everything I need to address to make sure that we're all on the same page. And I wish it would keep me oriented in the same direction when I try to go back to home there. So let us go ahead and just draw a simple shape because I'm not too picky here on what this looks like. We'll keep it as a rectangle. The M2 belt is, I think it's 1.5 millimeters thick. I've got one right here. Give me half a second. Let us see. M2 belt is, and I'm just checking parts really quick. So I have 6 pulleys. I don't see any idlers in my box. The fact of the matter is that a pulley can act as an idler anyway. It's just a matter of taking up more space because it has a set screw in it. So I may want to buy some more pulleys just to be on the safe side. Okay, yeah, I've got 1.5 like I remember on the GT2 belt. So we will go ahead and make this 1.5. I'm not going to offset this because we actually want it to squeeze the belt a little bit. All right, actually, here's the other thing I'm thinking about. This is not going to print particularly well, is the only other thing I'm thinking about here. Actually, no. Okay, we can change how we're doing this. Yeah, all right. So right now, I was drawing this to capture the belt going in parallel to the bed. That's not actually necessary. You can twist the belt and have it feed in the sideways here. So we'll go ahead and do that since we plan on printing in this orientation. We plan on printing as you're staring at it right now. So in order to avoid this really nasty overhang right here, we will go ahead. Yo, Wrath, welcome. We'll go ahead and just add that feature in after we get this resolved. And here's the other thing is that unlike the Prusa Mini assembly, back over here, where it has these jagged teeth, they're there, these jagged teeth to grip onto the belt, right? And just, these are the teeth of the actual belt, so they just feed right in there. It's not entirely necessary to do that. Many of the i3 printers, like in Ender 3, and I actually, no, the Prusa does have these teeth on it. The full-size Prusa does have the teeth on it. For the X belt, at least. I'm not really sure about the bed, but I assume so too. My point being is that so long as it doesn't slip out, that's the only thing you're worried about. So what most of these printers do is they throw a little clamp on the end of the belt so it doesn't slip through the catch. So basically you can imagine the belt getting, assume this is flat right here and doesn't have a space for the teeth. The belt goes through, and because the belt's only pulling in this orientation directly back, so long as you have a knot, basically a little clamp on the front end of the belt, that clamp can't get pulled through this hole right here, and therefore it stays in. So we're just going to go ahead and do that. We're not going to get fancy with these teeth here. And for the same exact reason, we don't actually need this to be that particularly thick. So I'm going to go ahead and just call it 10 millimeters. And again, so long as it's at or behind this line, we should be fine. So I'm thinking, I'm thinking we're just going to go ahead and line it up. No reason not to. And as for the thickness, so the belt, the GT2 belt is, how wide was it? 7? No, it's 6. Okay, not 7. But we can make it 7 and have an extra millimeter. Actually, let's make it 8 just to be on the safe side. It doesn't matter that this is sticking up past these knobs because again we have the spacers below these guys, so those spacers are already giving us the space before we hit the wheels, which actually there's nothing in between here anyway, so we could actually make this even larger if we wanted to. Just need to keep in mind what problems we might run into. And obviously this is on center. I'm going to symmetric extrude. The belt is only 1.5 millimeters thick, so if I throw a 3 millimeter wall on the other side of that, that would be 3 and 3 is 6, so 7.5 overall. And let us see. Do I want to do anything fancy here? I don't think I do. I don't think I want to do anything fancy with this slot. As I was saying before, it really is not necessary to, so I'm just going to actually extrude that out again. So get this profile right here. Symmetric. Hole size is 1.5 for the belt, as I said before. And that is that. Again, there's not really any reason to get any fancier with it. The belt will just slide through there. We'll put a little crimp on the end of it so it doesn't slide back through. It's one of those things, you might be a little bit concerned about it falling out the bottom here. It really depends on how tight it is. So if we wanted to avoid that, let's see. Just to be on the safe side. So I could draw, we could throw a little slide-in piece, a little clip basically over top this. It's not unreasonable. I'm up for it. The clip will just be pressure fit, I'm thinking, just to I'm just trying to figure out how well it will actually work to begin with, whether or not it won't slide out just as much as the belt. Yeah, probably just overthinking things. If I am worried about the belt sliding out the bottom, we can just make this 1.4. And so it's a little bit skinnier than the belt, so the belt should squeeze in there. Again, my 3D printer doesn't get exact sizes anyway, so it's going to be tight to begin with. So we're just going to trust the belt for this very small machine. It's not going to fall out. That is that. Now for, well, we'll mirror this really quick. Mirror it really quick just to get the other side. Features, doink doink, and the center line, or the center plane rather. Turn you off. We don't need you, construction line. The limit switch, how the limit switch gets kicked. Let's see, the motor is on my right side right now, correct? Let's check that really quick. Motor assembly, there it is. Nope, it's on my left. All right. So we want to do limit switch probably over here. And I'm probably just going to use that. Again, the limit switch. Nah, I guess I will put it a little bit ahead of these guys. I'm just trying to think if there's any reason not to just throw it as a little piece of plastic on here. I can't think of a good reason. Again, all it has to do is stick out to hit the limit switch, and it's going to be hitting the limit switch based on where the limit switch is sitting, which again we want to make adjustable to begin with. So since we make the limit switch adjustable, there is no we don't need to be terribly precise about where we're putting this piece of plastic, in which case I think I am just going to save myself the time and let us, from object, actually just offset, let's just use an offset, call this 2 inches. Okay, 2 inches is too far. 1 inch. Yeah, that's fine. Yeah, maybe not, maybe not. 20 millimeters. And then again, it's just a stupid little piece of plastic. Cool. And the limit switch will be sitting right over here, so let's go ahead and get that mount in here to have it done. Let's see. So this is going to be printed just in this orientation. Yeah, I can just print it off the front here. That's fine. Sounds good to me. So I'm going to pull my micro switch. Actually, let me get into that motor assembly first. There we go. Motor assembly. Open it up. Go into the back plate because the micro switch, the limit switch, is going to be part of the back plate. Modify align, get this in place, roughly in place at any rate, onto the top of there. I think it should be fine on top of there. I guess we'll see. Actually, yeah, I can tell right here. That's good. So it is below the bed. This is the only thing I was worried about, is that it was below the bed, and it definitely is. Okay. Again, I couldn't recall how thick this guy was exactly because it's been a while since I looked at him. And now we just got to get him in place, and we'll just use this front part here rather than the flap. In place there, and flip him around. And there we go. Yeah, that's fine to start off with. Again, I'm going to... Actually, no. I take it back. I take it back. Let's slide you over to where that limit switch, limit tripper, I guess we'll call it, actually is. There we go. Now we can go and start drawing. Okay. So let me go ahead, capture position, and we're going to draw, actually come up here to the bed and toss a construction plane off of that so that we know where we're drawing. So construction plane on that, and this is inside of limit trip. There we go. And now we can come back up to the back plate and get on with our lives. There we go. I'm just drawing it from the side because it's easier to do the overhang here. Again, because this is 3D printing, I want to make sure that whatever I draw here is easy enough for the printer to print, which means that I want... again, I can do up to 60, is not terrible, but I'm going to keep it at 45 just because that's super easy for the printer. Well, relatively super easy for the printer at any rate. Now this distance here, we got to be, it should clear the, all right, so this will clear. I think this is going to clear the wheel. We might have to slide the limit switch over actually a little bit to make sure it clears that wheel. So this 20 millimeters right here might get reduced down to 15 just to make sure that we don't run into a wheel, because the wheel again should get as close to the back wall as possible before the limit switch trips in order to give us the maximum amount of overhang off the back wall. Also, I just realized that this bracket has to be back a little bit. We will adjust that in a little bit. I'll come back to that. And it needs to be back a little bit because, again, this back lip right here is going to overhang the wall. Although, just looking at it, it's one of those things I thought we had more overhang than we do right now. So I was overestimating the overhang is what it comes down to, but that is not that big of a deal. So this distance here, as I've been trying to get out of my mouth for a little while now, is basically whatever travel we want this limit switch to be. And again, so long as it clears the wheels, it can be any number we want. One of those things, all we're doing is just wasting space, wasting plastic by making it too long. So I think since we expect our model to be fairly accurate, I think I'm just going to keep it at something like 5 to 6 millimeters. Yeah, I think that's fine. And then off the back side here, for the back side of the, so where these screws actually go, right? We're just going to do the same exact thing. So this is going to be 45. I'll drag that out so we can actually see it. And actually, just to make everything kosher, do that. And let's see. We're going to want this to be whatever this is right here. So the difference between that and that. Whoops, not that and that. That is definitely not what I want. So that is, what do you say? 3.45 is the distance. So we need at least 3.45 plus whatever swing we want out the back. So I mean, let's just call it another 5 millimeters. So let's call that 9, just a generic 9 to round. So we can go 5 millimeters forwards. That will get this front face up to that point. 5 millimeters swing forward from this neutral point. And then backwards, we're going to have 5 millimeters in theory. Now, I say in theory because one of those things, the way I drew this, I did not actually leave a lip for the screws. So I should probably just fix that. One of these things, right now the screws will be coming through and they're not really contained. And if you don't know what I mean, I kind of want to just draw it so that you can see it, but in theory, this overhang is just for the printer. It's not actually for the hardware going through it. The hardware going through it kind of actually just wants an open space. So, I guess that... Oh, this is stuck on the center line. That's why. This I want to be... Oh, you're also stuck on the center line. That's why. This I want to be at least 5 millimeters, which is fine. That is 54. 5 millimeters is fine there, and then 5 millimeters on the back as well. And now let's get you fixed because, yeah, come on, click. All right. What is wrong here? You should be a profile. There you go. Now you're a profile. Are you a profile? I think you're a profile. Okay. There you go. Much better. Let's extrude this out. Distance to object. That guy. And then I'm gonna cat. I guess we'll just do this from the top. That's fine. And we want to go down 5 millimeters so that we're at the bottom of that. Okay, that was up instead of down. -5. There we go. And we just want to grab these screw holes and then draw the slots in from here. So, not that one, tangent. There's that. There's that. And then collinear here and here. And then we can extrude that out. Attempt to extrude that out. Turn the body off. That is the bed. I want the bracket. There we go. I guess I should probably also make these construction lines so they don't get in my way. There we go. Body and distance to object. I kind of want to come down to here. There we go. All right, there is that. So I'm going to do the slots for the screws next, but I wanted to get this in here just so you can see what I was talking about before. So the screws are going to come down here, and I just wanted open space for the screws because the bolts are going to hold them up here, so it doesn't necessarily matter whether or not they're captured or not. This just gives me extra open space to slide them around. Is the whole entire point. When I had the 45 angle all the way up to here, you can imagine that all of a sudden I draw this 5 millimeters down, right? And to give myself meat for the bolts to bite onto. And I could have made this 3. I decided to make it 5. But point being is that all of a sudden this looks a little bit wonky with the cutout here going through all of that angle. Now I've got this nice face right here for the bolts to bump up against so that they don't slide out. So that is that. And technically speaking, actually, I said 5 millimeters is what I wanted for swing. I didn't account for the wall thickness that I want on the end of the swing. So I should back in here. And again, wall thickness, I'm going to lean towards 2 millimeters just because, whoops, that would have been 5 plus 2. Is what I meant to do. just because it's not going to have any real strain. Strain is a fine word for it. Any real strain on it to make it blow out. So I'm not that worried about it. Where is my micro switch? There it is. Get out of my way. Get the body out of my way. And now we can go ahead and toss these slots in here like I was talking about for the screws. Slot. 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 There we go. Actually, yeah, this is fine. Alright, slots. This is going to be tangent. That is going to be quinkadink. Quinkadink and tangent. Now we know that those are the same size. We can go ahead and do that and make this perpendicular to that guy to make sure that these guys are on the same, or yeah, the slots are the same size is what I'm trying to say. There we go. And now we can use that as our 2mm reference that I was talking about here from the edge. Oh, that is an angle. Let us make sure that these lines are actually parallel to... Okay, they are. So why did you give me an angle? Alright, these are parallel to the wall. These are perpendicular to each other, right? Oh, okay, this guy is not parallel to the wall. That is why. Okay, gotcha. That would explain that guy. And you are parallel to the wall? It looks like you are. Yeah, okay. Looks like we fixed it. So anyway, my 2mm wall thickness right here. 2mm. Can my machine make threads for screws, Gale? Not really. So you could try if you wanted to, and it might turn out okay. So it will model it, and it will probably be pretty close. The problem is that plastic is really soft, you know? So if you put the threads in yourself, it may very well tear out. The alternative, where it's not going to be as likely to tear out in my experience, is to just make the screw the hole size undersized, and then just have the screw cut the threads in itself. So the screw, being metal, will cut through the plastic and make its own threads that it will, will conform to it better. And that's less likely to tear out in my experience. I haven't actually tried putting threads in manually. So, one of these things where, I don't know, maybe it works, but it just does not seem like a good idea to me, frankly. Nah, I'm not going to say no thread up breaking. I'm just saying because the threads are so... because the threads are formed by the steel screw itself, they are right there flush, completely flush to the threads of the screw, and therefore they have less room to wiggle and shear. They can obviously still shear. They definitely can still shear, but they're not going to have as much space to do that in. And whereas the other problem, if you model up the threads, is if you start cross-threading it, the plastic's just going to give way, right? So you'd have to thread it perfectly in there, and they'd have to be perfectly formed. And it's one of those things, a thread is an overhang to begin with, and most thread pitches are... Let me just do this really quick. Most thread pitches are actually pretty rough overhangs, so let's extrude this out really quick. Actually, let me do a hole instead. Give me that guy. There's this. And then let's toss threads in here. So there's a thread, and I want this modeled. So you can do this, and you can tell your printer to print this. Now, if I take a cross section of this, oh, derp. I don't have any cross sections up right now. Haven't needed them. Section analysis. Give me the YZ there. And let's find the middle of this. There we go. So I said 45 is a good angle, right? If you look at this angle right here, which is the tooth angle. Let's see. Actually, I'm going to back up here, put you on center to make my life easier. And then I guess I hit Control Z instead of just backing up, because I do that a lot. Thread, got that in there, modeled, okay, back to where I was. And now instead I'm going to go into a sketch because I want the intersect of it, and it's easier to get the intersect in a sketch. Okay. Intersect a body, not intersect a face. There we go. Intersect a body. Here we go. Alright, let's turn the bed off really quick so that we can see what we're looking at. Bed is off now. And we'll turn this body off. There's that body off. Alright, here we go. So this is what I was trying to show you. So I said 45-degree angle is what is nice. You'll see right here. So your tooth, the teeth on the threads right now for this specific model is 60. Again, 60, as I've said before, is pushing it. That's a very well-tuned printer. So the fact of the matter is that the printer, and actually let me even do this just to do one better. I'm going to draw a line in here and then put this at 0.02. So this is 0.02. Yeah, 0.02. Yeah. 0.02 is the standard print height. That's the standard quality print height. Okay. So each one of your layers is going to look like this at the microscopic view. So this is where one thread that your printer lays down is, and here's the thread below it. So you see this is not actually a straight angle. It's actually this stepped formation. When you zoom in all the way here where, 0.02 millimeter height, this is what it looks like at the 0.02 millimeter height. So not only do you have a pretty severe overhang, relatively speaking, 60 degrees, and the distance here is 0.035, right, for that overhang. So that's more than the thickness of your layer. Let's see, 0.015, 0.02, so that's like 3/4. It's 3/4 of your layer height as overhang. 3/4 more of your overhang. 175% of your layer height as overhang. So it's one of those things. It's just, it may work. It's just going to be rather janky. It's better to just have the screw cut it in itself. So yep, that is the deal there. And we will now go back to your regularly scheduled program. Yep, I can turn that back off. And that limit switch now has the whatchamacallit in it. The slots in it. So there it is. Let me go ahead and add a slider in here. Oops, nope, not that one. As built joint. There we go. I guess just that and that is fine. And slider, I want to use this guy right here. And hopefully, yeah, cool, nice. All right, set the limits while we're here. Edit joint limits, and this was plus and minus 5. 5 and 5. Minimum would be minus 5 rather. Okay. Technically it's a little bit more because I only did this line right here, so we're missing out on half of this screw size, but as you can see, at least it's relatively demonstrative of how that limit switch slides forwards and backwards. Actually, the minimum, I'm looking at it, and part of my problem is that the minimum should also include the wall thickness, I think. So like another 6 millimeters is the deal here. Edit joint limit minus 11. And let's see what that looks like. Yeah, there you go. So you'll see if we look straight down here, now that's much closer to the front of that. Again, it's a little bit off because I don't have everything lined up exactly, but again, this is just for demonstration purposes, having this joint in here. So we can adjust the limit switch forward so that the bed stops earlier, and adjust it backwards so that it stops later. Cool. Now back to this bracket. So let's see. I have an 8-inch bed, 4 inches. Let me grab my pair. We did all this math on the previous stream, dropping bolts that I had out. Let's see. So it looks like 35 plus 12 plus 5. What was the 20 for? The 20 was my extrusion. Okay, the 20 was my extrusion. So 35 plus 12 plus 5 is 40 plus 12 is 52, and I think that's everything. So I think in theory, oh no, that's not accurate. So we need to go, let's see. So it's 4 inches minus 35 minus 12 is what I believe it is. No, minus 4 inches minus 4 inches minus 35 minus, actually it should be the full size of the wheel is what it should be in order to get our overhang. So it's from the center of the bed to where the wheel starts. Actually, the 35 is to the center of the wheel. Okay, the 35 is to the center of the wheel. I don't feel like turning my camera back on. That's why I'm just reading this out to you. Again, if you watched the last stream, then these numbers should be familiar. It's 35 to the center of the wheel and then another 12. That's why we only have half the wheel. So 35 plus 12 gets us to the edge of the wheel, the opposite edge of the wheel. And that should be what is hitting the wall. So 35 plus 12 is 47. So it's 4 inches minus 47. Calculator. 4 times 25.4 minus 47 is 54.6 is in theory the overhang that we're supposed to have off the back of this. We go ahead and minus out this wall thickness, which is 6 millimeters. So let me data that. 54 minus 6 is 48. So this bracket needs to actually start 40. Well, actually the stepper motor itself actually needs to move about 50 millimeters back. So let us go ahead and do that. I'm gonna hop all the way up top because we moved the stepper motor before we started working on the bracket. That is not that move. Where is the move for the stepper motor? This guy? Nope. Are you sure it's not this guy? What is this guy? Okay, that's the eccentric nut. And this is probably the other eccentric nut. It is. Alright, there's the motor. So this guy needs to move another 50 millimeters back. Move Nemo motor minus 50. Or I guess just 50 because evidently that's the positive direction. Finish position, and now we're gonna have to check. Alright, our bracket did update itself. So our bracket does look a little wonky right now. It kind of makes me want to change this to come down to intercept this, which I think I will do, just to make it look a little bit thicker and less likely to just completely shatter on first use. Let's see, so that's going to be this, not that sketch. Nope. The third one in line here, that one. So let's go ahead and draw a line from here to there and tangent, and then I will just adjust the extrusion. And that's that guy plus that. Okay. There we go. Now it looks less likely to just completely explode the first time I use it. And now the bed should be able to slide all the way back to this limit switch and stop before it hits the stepper motor. That is the plan. So now that we have everything in place, actually, nope, we do not have everything in place. Actually, we still need the idler wheel in the front. So where is the front extrusion? I'm gonna minimize that. We can leave the bed on. We want to turn the motor assembly off though. Alright, motor assembly is off. We don't need that anymore. I do, however, want the front extrusion. There we go. We will go ahead and keep this as part of the bed assembly since the back bracket is also part of the bed assembly. And we can just do it on center line, I believe. Yeah, we want to actually do it on center line. That's definitely something we want to do. So, unless, so we don't necessarily need to do it on center line. We can line it up on center line. Nah, let's just do it on center line. This is fine. So we're just going to draw a bracket to hold onto the idler pulley that is in the front hand side. That's what we're working on now. Yeah, actually, I'll just grab the front face. Actually, I take it back. We don't want to grab the front face because the front face is at an angle. So we'll just grab that instead. And the floor. Actually, I guess instead of that front face. No, we do want the front face. Grab that. And I will need the center part here because we need to place the screws for the... I don't need this now. We can grab that later. I was going to say we are going to need to place the screws. Yeah, alright. I'm going to get rid of top and bottom. We'll just do it based off this front thing because it's just free floating in there. It doesn't need to be attached to the floor. And the only other thing we need to project though is... And I turned it off, but that motor assembly, we need to project the pulley because in theory it should be in line with the pulley. So turn the motor assembly back on, project the pulley, and we want to make sure that we stay parallel with that. So, do we need the bed? We actually don't need the bed right now. So I'm going to go ahead and turn all that stuff off. And we can turn the motor assembly off now, and then we should be good to go. So we're going to go ahead and take this. Horizontal is fine because everything is based off of, all the designs are based off of the origin, and therefore horizontal is parallel with the ground. So I'm going to bring it over here. And the idler pulleys are the same diameter if I recall correctly. Again, I don't have any on me right now. Evidently, I need to order more, but I believe they are the same diameter as the actual, what do you call them? The set screw pulleys for the shaft. So I'm going to go ahead and make this equal to that guy as a reference. And we can make this a construction line, and then we just need to draw in some connections. So that is equal now, so we know that. Actually, let me go ahead and also include the center hole because we're going to need to build around that as well. So one of these things where that can be a construction line, this is their center hole. The wall thickness here, if I make this 3 millimeters, that's fine. So this is the bracket is what I'm drawing right now that will go on either side of the pulley. The pulley will have a cutout in the middle, and we can go ahead and give, we don't really need to give it that much space, so I'm just going to go like a millimeter of breathing room. And then, actually I will leave that solid. Will I leave that solid? Nah, I will not leave that solid for right now. And then I'm just going to go tangent to this guy like this, I think. I can't think of any reason not to. And then the only, let's make you guys, I don't want you guys to, but those guys construction lines, and then we can go ahead and draw the actual backside right there. Now, anyway, as I was saying, the distance here is honestly probably just as close as we can get. So this 1mm space right here is probably all we bother with. Actually, let me pull the bed back up, just make sure that I'm not going crazy here and we're not going to collide with the bed. Project that. Okay. And draw a line out just to make sure. Turn the bed off really quick. Okay, we are clearing it. It's closer than our... Actually, that looks to be actually hitting it. Okay. So this is going to need to be a little bit lower, unfortunately. I don't like that it's lower because that's going to pull down on the bed a little bit. The back pulley right here on the motor is all the way out behind where the bed will reach, which is why it doesn't matter. The bed will not collide with it. This front one, however, as you can see, is going to collide with it where it's at right now. So it is going to have to be slightly lower, unfortunately. So I'm just going to delete this because at this point, that line is no longer what is relevant. It is this line right here. Well, technically this line right here. But point being is that this is now going to have to determine our tangent. Again, I'm just going to leave a millimeter because we don't need much. You don't need much. So it's just going to have a millimeter space below the bed. And this is assuming the bed does not pull it down into itself, which is potentially something that could happen. But I'm going to trust everything right now. And again, for this distance here, which is what I started to talk about before we got sidetracked, it doesn't really need to be much, so I'm just going to go tangent there. Again, that 1mm, it's not going to hit the... Actually. Back to I need to mount this. So, as you will recall, I like having flat surfaces to mount to. And that just took me to the center of the bed again. So, let us go ahead and disconnect this guy. You go away. Disconnect this guy. You go away, and then we can go ahead and draw in a flat surface to connect the T-nuts to. These T-nuts will come through this plate right here that I'm drawing into here and connect the bracket to the extrusion. And now this can be tangent to that. That can be connected to that. That can be connected to that, and that should be everything. So the last thing we need to dimension is just how thick this bracket is, which I will go 3mm. And as you can see, the sketch is now completely constrained, so we can start extruding it. And again, just like the holders in the center of the bed for the belts, I'm going to extrude out the whole length of it, and then just cut out the center part for the pulley. So, the pulley, actually, I take it back. I take it back because I'm going to go ahead and... Did I really put this? Alright. You may recall. No, actually, I take it back. Okay, I take a lot of things back. I know I take a lot of things back, but I have changed my mind. So back to the motor assembly. I was thinking I was going to put this inside the motor assembly is what I was thinking in my head. And I did not do that. Obviously, the sketch is out in the bed assembly, probably because of me bouncing around. So I will, however, hop in here now before I extrude this. And I will bring in that idler pulley and align it up with that sketch now. Modify align. Mr. Idler pulley, come back here. Oh, I haven't turned it on. That is what happened. Okay. So align the center of you with this sketch right here. And then now you are in place. So now we can, now I will extrude around that and actually make its own component. I can do that as part of the extrusion. Let's turn you off just for a moment so I can see what I'm selecting. And we will go ahead and extrude. Whoops. I'm already in extrude. I don't have to hit E. Two-sided. Two object. I'm going to go ahead and use the idler as reference. So there. And then offset by 3 millimeters for my wall thickness. And the other side does the same exact thing. I could do symmetrical if I wanted to check what the size of this pulley is, but I don't, so we're doing it this way. Laziness wins. New component, and hit OK. I thought I hit OK. Obviously I did not. Idler pulley, bracket. Hop in here and start making our modifications. So now we're going to extrude out the center part for the idler pulley itself. And I actually do want to come back in here now because I wanted to take this 1 millimeter section clearance and use that as my clearing of the center part. Let's turn that off so that I don't accidentally cut it. And we will turn the body off for half a second. So let's just click all this. And I don't think I'm missing anything there. So turn the body back on. Turn the idler pulley back on. Distance to object. There. Actually, two-sided. To object. There. And distance to object. There. And then we can just make this a cut and make sure we are not cutting the idler pulley. And it looks like we are. Oh, we're somehow ended back up in the bed assembly, which is annoying. All right. Okay. Try that again. Turn them off. Grab the profiles. Turn them back on. Two-sided. To object, that side, that side, and make sure we're not cutting the idler pulley. Huh, why is the idler pulley not on the list? I guess because it's in an... So there have been times where I've done this and it has cut the idler pulley, for example. I guess maybe the reason why it's not is because back to they make it so you can't edit in place without the paid subscription. That may be why. Yeah, minus 0.2 I guess is fine. Alright, and this will just get a bolt and a lock nut on it, so we don't have to do anything fancy with that. The last thing we gotta do is add the space to mount the T-nuts, is the last thing we need to do with this. So let us turn off rather the front extrusion. Where's the front extrusion? There it is. So we can see what we're working with. We can turn that sketch off now. Turn this on. Label it as back of idler pulley bracket. Back of bracket just to save some typing. Project this as our base. Keep this the same width just because we don't necessarily need to. It just, in my opinion, makes it look cleaner. One thing I will say is back to printing this. So when we print this, this is going to want to print like this in this orientation. This is the orientation it's most comfortable printing. Technically speaking, I guess it could print in this orientation and not be too bad off. So yeah, those are options. I'm just saying it because it's something new we need to keep in mind. Yeah, actually, I don't think it would be that bad if we print it in this orientation. Yeah, that's fine. Only point being, only place I was going with this is, again, remember your overhangs. So if we print it laying down like I was just suggesting a second ago, then this overhang is actually kind of bad, but it doesn't look bad enough to me. This one is much more shallower, so this should come out pretty clean if we print in this orientation. The only reason we're able to print in this orientation, in my opinion, safely, is because we added this 3mm set out right here, so it's going to have a base to sit on. Otherwise, the widest base to sit on would have been the back plate, but because we brought this out a little bit for the plate, it's going to have enough meat to grab the bed and can be printed like this. Again, these overhangs on the inside here don't necessarily matter. The screw's just going to go through them, and then it's not going to be that big of a deal. So that is that discussion out of the way. Let us grab this. I'm going to center this on that line, attempt to center this on that line. Which one is it? That one? There we go. Just so that I don't have to dimension two things at once. There's my center of this square. We will use the M4s. So that is a 4mm M14 nuts. And then I just want to give myself some meat around there to have something to bite onto, and everything else can be tangent. So we'll make that tangent there. And there we go. One of these things, again, mirroring versus just really quick drawing this in here. I think I am just going to really quick draw this in here rather than mirror it. Actually, no. Because this is dead center. If this was not dead center, then I would draw it in right now. But because it's dead center of the origin, right there, because it's dead center of the origin, that makes mirroring it a lot easier. So I'm not going to worry about it. So let's go ahead and get this side extruded then. And actually, it's one of those things. I'm trying to decide whether or not I want to make this look a little bit fancy, and I guess I don't. I guess we are not going to bother, although I probably will round the top corners like we did before. So I believe we said this was 3mm. That looks like I was correct. Join, and I will round the top corner since we plan on printing in this orientation. 6 looks nice, and now we just mirror that over. Easy peasy. Mirror features, these two, and the center line is the origin. That's interesting. Is our origin off a little bit? It does look like our origin is off a little bit from the actual origin. That is fascinating. Why is that? If I hit the front view, we are lined right up with that. So why is our origin off from the actual origin? That is strange. Huh. I wonder what this is. This is very odd. That is the main origin, right? So we should be able to... Interesting issue. Let's try this again. Maybe I just clicked something weird. Please. Thank you. Click. Identical. Front view. We are dead center with the origin. What is going on here? Alright, well, in that case, guess who's not going that direction with this? This guy. This guy's not going that direction with this. We are going to just draw this in, and I'm not going to lose sleep over this. So, just extrude that out, and then adjust the fillet to have both corners. Adjust the fillet to have both corners. There we go. One of these things where I'm not terribly worried about the model being slightly off on this guy, because we're going to line this up by hand when we assemble this. So it's not that big of a deal. We can fix it ourselves. It is, however, weird that the center line is not working. I will admit that. That is very odd. Alright, turn everything back on because I believe we are good. The last thing we probably want to do is find that rigid group that handles the motor and add this, move it back and add this guy to it. Actually, it looks like that might be the last one here. Yep, that is the last one here. So we want to go ahead and add this guy to that group. And now everything should be held together. It looks like I am missing some wheels though, so let's fix that. Which joint is that? Just the rigid? Okay. There's that. Where's the rest of my wheels? There's the rest of my wheels. And the bed. The bed is also important. Turn that sketch off. Turn all these origins off. That somehow got on. Oh, darn you. Forward. 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 Alright, cool. I'm gonna have to turn those off like this because find in browser. Because the origin is not an distinct object, it is a group of objects. So we can't actually just click it and turn it off. Just like that sketch line right there. We clicked the sketch line and it turned off just the sketch line instead of the entire sketch. Find in browser. There we go, much better. Okay, now the last thing is after I mirrored these wheels, I'm wondering whether or not these wheels are, nope, they are not attached. So let's go ahead and get that fixed really quick. Find the bed. Is this the last thing we did on the bed? Yeah, that's the little trigger switch. So we should be safe coming to here and making a rigid group of all that stuff. Rigid group. We do not want child elements though, just because that could play mayhem. We want these guys. Actually, let me deselect that just to make sure that I'm grabbing all the right stuff. We want the body, or the bed rather, the bed, eccentric nuts. I think I can do the wheels themselves. Not the motor assembly stuff, the spacers and the wheels, and that should be good. The wheels are multiple components that have revolves on them. That's why I was hesitating for a second, and it looks like actually the wheels did not take. So let us come back in here and adjust that. And instead of doing that, do the wheel here on each of these, and that should work. View roller, wheel, view roller, wheel, and wheel. Alright, close everything back up, hit OK, and okay. So when we mirrored those objects, they lost all their constraints, as you can see right here. That is a bit obnoxious. I am not going to fix that on stream. That will be something that gets fixed off stream because I'm not going to waste your time with that. Okay. So that is, in fact, I believe, absolutely everything done for the Y-axis. I don't think we have anything else that needs to get done. Let's see. We've got the motor. The motor drives the bed. The bed is complete. The bed has eccentric nuts on it to tighten it. The bed has holders for the belts to make sure that the belts move. It has the limit switch, whatchamacallits. Let me head to the end of the thing here. It has the pulley on the front. It has the brackets to hold everything together. I haven't modeled it up, but there's screws getting tapped into the back here, so that's fine. Yeah, alright, I think we are done the Y-axis. So we can now move on to, and by now I mean the next time we work on this, move on to the Z-axis. And the Z-axis again will carry the X-axis, and we will go from there. So, yep. Yesterday was a 2-hour stream. Today, hour and 50 minutes looks like we're hitting. So that's in total of 3 hours and 50 minutes, which is like 20 hours more than I thought this was going to take so far. Again, I ran into it because of all the constraints I put on myself with how exactly I wanted this designed. I ran into a whole bunch of extra things we had to solve that we're not, we're only there because of decisions I made during the design step, during the design process. As you can see, this could be a lot easier. I could just have linear rails here, and then we have a lot less to worry about. The extrusions are causing us a lot of problems. So, are causing us most of our problems because we got to work around the extrusions. We could have gone other directions with this and made it a bit simpler to design and a little bit quicker, but we did not. So, glad everybody's enjoying it. Glad to have you guys along with me on the way here, and very excited to be moving on to part 2 of 3 in the overall physical design of it, which would be the Z-axis. And then the X-axis, frankly, is a lot actually the X-axis and the Z-axis are both probably going to be pretty easy. They're probably not going to be this long. This is probably the longest. This is the one that has the most complications, I think, because the X-axis just has the carriage on it, just has the toll plate on it. So that's not that big of a deal, unlike this, which has the whole entire bed that we have to accommodate. And furthermore, the X-axis will only have the extrusion that we have to worry about. It doesn't have this whole entire frame to worry about. Same thing with the Z. The Z is just going to move up and down on the extrusion. One of these things, I'm half tempted to get linear rods and linear bearings for the Z-axis just because it makes it so much easier, but I think I'm going to hold off and just do it with the extrusion. So that is the game plan moving forward and what you can expect moving forward. Again, thank you guys for showing up and watching. I really appreciate it. And if you don't mind, do show up for future streams because it's nice having people around. So anyway, as always, I hope you guys have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you guys next time.